Okay, video 3, NASA hunch door left. So we kind of did this face, did the sides. Next thing I'm going to do is these side holes here. I know we didn't do the slots yet, but if you do the slots first, you have the chance that your drill is going to walk a little bit when it hits these surfaces, and so that could mess up your tolerance on the hole. So I do the holes first and then the slots after. So we'll take a look real quick at those holes. They are 440 tapped, 870 deep on one side and 370 deep on the other side. And there's a counter bore, 127 thousandths, 230 deep on this side and 730 deep on this side. Alright. So I'm going to go ahead and I'll make a new toolpath group. And I'm going to call this one 440 holes, caps lock. Let's see, B90C0. Go ahead and move that plane to the origin right there. And the B91, actually I just might as well do them all, right? Alright, so let's see, you'll go with B90C0 for my construction plane. Go ahead and do a drilling toolpath. Select the hole right there. You check. Tool is going to be spot drill. Where'd you go? Tool number 9. Those speeds and feeds. The spot G81, G82 spot drill. Alright, so let's see now. Might retract. Click on that surface, which is 3.067, and then I'm just going to add 100. Top of stock. And my depth is going to be 3.067 minus. This counter bore is 127, so we want a little edge break on there. So probably go 130 diameter, half of that is 65, so minus 0.065 gives me 3.002. And then I'm going to add clearance because I'm going to rotate the part around and do the other hole on the other side. So I'm going to give that, I'll just say 2-inch 5 inches. Alright. Let's see. Coolant is on. Green check. Then we'll go to the 180 plane. We'll do the same thing. Okay, same tools, speed and feed. This time my retract is going to be a little different. And then my depth is going to be the 2.859 minus 0.065. Check that. Alright, I'm going to drill again. I'll use the copy previous points. Check. Tool is going to be the 125 drill. Tool 14. Alright, so speed feed. And this time I'll go with a pick drill. And this UMC machine gives us a lot of options. Go with a 50 thousandths peck as a cue. Let's see, linking parameters. So my retract is good, my clearance is still good, my top of stock needed to be changed, and now the depth. So this hole here, 125 goes down to the bottom here where the tapped hole starts. So I'm going to use that for my depth. And then I'm going to go a little bit deeper, and that'll act like a spot for the drill that comes next to do the 440 thread. So I'm going to just I'll go 2.1, see what that looks like. Check. Goes past that, and then there's my 440 hole right there, and so it's going to give me a little edge break on that, so that looks really nice. Green check on that. Go back to my solid display. Alright, so we drilled that hole. Now we'll flip it around, drill the other one. So back to my B90C0. check. Same drill, same cut parameters. Just got to change my linking. And my depth for this one is going to be right there. And minus 29, which is how much deeper we went on the other one. Alright, just like that. Right there. Very nice. Alright, so now I'm going to come back through with the end mill just to finish that counterbore, and then I'll go and drill and tap the threads. Next thing we'll do is we'll put the flat bottom on these holes for the counterbore. So I'm going to copy these two drilling paths we just made. I'll start with the last one we did to keep the same rotation. So copy after, and I'll take number 11, copy it after that one. Alright, so we're going to go ahead and change to our 1/8 flat end mill. $2,505 inches a minute, and it's just going to be a normal drill. So zeros on that stuff. See, linking should be right there. Everything else stays the same. Flip over to this one. It's a little deeper. See, maybe. Alright. This one. Tool. 18. 2,500. 5. Zero on those. Alright, so now we got our counterbores. Time to drill and tap the holes. So we'll come back with another drill tool path. Now we need the drill for the 440 tap, which is tool 15, number 43 drill. Alright, normal peck drilling. Yeah, normal peck drilling is fine. Linking parameters. Actually, I'm going to retract down to here. My depth is going to be right there. And I'm going to activate tip compensation. So that's going to bring the shoulder of my drill to that right depth right there. So let's see. That is a depth of top stock is 2.59. .048. There we go, 1.048. That's what they tell us to drill to. Looks like our model's matching our print, which is always nice. So, check that. Same tool, 43 drill, speeds and feeds, pack drill, linking. So retract on this one is going to be right there, top of stock, right there, depth, there, tip comp 0. Let's go ahead and tap these holes now. So just go ahead, I'm going to copy this toolpath down. I'm going to copy this 15 after 17. Tool is going to be the 440 tap. Feed rate 10 inches a minute. Change to tapping. I'm going to get rid of all this stuff. We don't need any of this. So clearance, retract. Let's see, retract will be +0.1. Top stock. And my depth, so no tip comp on a tap. Depth is going to be from here. And then we'll look at the print, see what they call out. 370. So minus 0.370. And then you may have to adjust that depth based on the tool that you end up using, how long the lead in might be on it. I'm just going to go another 10 thousandths on ours. So we have a kind of a bottoming tap, so there's not a big lead in on it. So that should be good. All right. Check that. Another hole. Do the same thing when I choose the 440 tap. 10 inches a minute. G84, 74 tapping. Again, change all these to 0. We don't want to add any funkiness into our can cycle. Alright, so clearance is good. Retract should be plus 0.1. Top of stock right there. No tip comp and depth. Start from here. Check our print again. Now we're on this other hole. So it's 870 depth. So, whoops. Minus 0.87. And again, I'll go another 10. So with the 440 tapped holes done, I can go back and get these slots taken care of. That'll be just about everything for that face, except for when we get close to parting it off or tabbing it. So let's see, minimize those, and I'll just go with call this group slots. Back to my B90 C90 plane, and then I'm going to go with a contour. I'm going to choose solid selection, loop. That one and that one. Green check. Tool is going to be tool number 5. Alright, speeds and feeds are good. And we're going to do a wear compensation. We're going to do a ramp with a ramp depth of 20 thousandths. And I do want to make a pass at final depth. Okay, no depth cuts on a ramp, so lead in, lead out. It's going to need to be small. There's what the slots are only about 200 thousandths wide there, so there's not a lot of room for a lead in, lead out, so we'll just make it nice and small, 5%. That, and I want to enter and exit at midpoint. Okay. No multi-passes. Alright, linking parameters. So top of stock is right there, 1875. 1.25 for the retract, and the depth is minus 0.1125. You can just verify that real quick. And coolant is on. Green check. I guess we could have made our lead in lead out a little bit bigger. There's some room there. Let's see. Make it 10. There we go. Save that. Alright, now that we got the slots done, we can start working on this side. The first thing I want to do is I want to make this flat, which gives us our thickness here, and then we can do the round feature across the top and these holes, and then we'll start working on the angled face. So, guess I'll do a new toolpath group. So this is going to be 270. Sorry. Alright, so go ahead and do a contour. Single edge. Choose that guy right there. Check. Go back to my 2-inch insert mill. Cut parameters is going to be compensation type will be off. 2D contour. We'll go back to my normal 40/40. I shouldn't need to adjust the starter end of the contour because I already trimmed the ends. Let's see, done meeting multi-passes. Let's do depth cuts, and it's about 125, so, or no, less than that. Let's see. Top stock is 0.25. My depth is going to be 1.875. So that is about a 16th, so 62. Alright. For my depth cuts, I'm just going to go 0.1 is my maximum rough. I do one finish pass at 5 thousandths. Alright, and linking parameters. That all looks good. Coolant's on. Green check. Alright. Yep, okay. Alright, so now that we got that flat machined and we have the backside already done, before we start removing a bunch of material from here and losing our rigidity, we can go ahead and do the round over with the corner rounder. So let's see. I'm going to first draw a line from the midpoint here to the midpoint here, just like that. And then I'll go toolpath, contour, single wireframe entity. Pick that line I just drew. Tool is going to be corner rounder. Where is it? 060 corner rounder. Okay. Change the name of it. Alright, so 187 radius mill, 060 tip. Alright, so let's go with 100 surface speed. Alright, feed rate's good. Let's see, did they put the Harvey number on there? No. Okay, that's fine. So, speed and feed. Cut parameter is going to be wear compensation. 2D contour type. No depth cuts. Lead in, lead out. Now, we're going to have to increase this because the lead in, lead out percentages comes from the tip, right? With the corner rounder, you have the tip is only 60 thousandths, but you're cutting, you know, at like 3/8. So you want to increase that lead in, lead out, so you don't come down with the tool on the edge of the part. So for my lead in, lead out, I'll usually just, instead of going percentage, I'll just put a number in here. So I'll just go 0.1, 0.1. It's going to come out to some weird percentage. That's okay. Alright, and then linking parameters. So the radius here is 375. Half of that is 3/16, 1875. That's the radius of our cutter. So our depth is going to be actually 0, because that's where the line we drew is, in the middle there. So we're going to have to do from this side and then rotate it around and do from the other side. Alright, and corner rounder does have a little lead in, so even though, so your radius is 1875, you actually have to go a little deeper than that, because there's a little lead on the tip of the corner rounder. Now, sometimes people will make that adjustment at the machine, and that's what I like to do. I feel like it's safer that way, because if I go an extra 5 thousandths deep in my program and somebody makes the adjustment at the machine, now we're 10 thousandths deep and we're going to gouge the part. So I'm not going to make any adjustment to the depth. I'll do that with the tool at the machine. Alright, green check. And just do a back plot to show that. So even that big lead in we did was almost not enough. Like that. Boom. Alright, so now go to my planes, go back to B90, C90, and I'm going to run that same toolpath again. Now, if I wanted to, I could take this toolpath, drag it down, copy after. I could go to parameters. I could go to my planes and just change my plane, the tool plane and the construction plane, to B90 C90, green check, and then I just need to flip my geometry because I'm going the wrong way, right? So do a right click, reverse, and a right click, change side. So now I'm going the right direction with my offset on the correct side, and I'm climb milling. So green check that, regenerate, and there we go. So save that real quick, and I'll do a quick verify. Alright, looking good. Stuff up. Alright, my plane back to here. Oops. Doesn't work. Okay, so the last thing we'll do for this video, and before we start getting into the pocket and stuff, is these two holes here. So if we go to the drawing, see those are the two helicoil holes. So for helicoil, you have to drill with the drill specified in the catalog, and then you have to use a screw thread insert, or STI tap. So it's a 256, but it's a 256 STI tap. Which is different. It's bigger, of course. So you're making basically an oversized tapped hole, then you screw in the threaded insert, and now you have a 256 hole. The helicoil catalog tells us for a 256, so this section is where you spend most of your time on the catalog for programmers. You see here, it's about halfway down. It's like page 16. It starts, so you have inch drilled hole dimensions, and then you have metric drilled hole dimensions, and then you have inch tapped hole dimensions, and then metric tapped hole dimensions. Alright, so the tapped tells you need the countersink at the top, and that's how big they want it, and then how deep you need to tap for the length of your insert. Alright, so we're doing a 256, so we want to use a 3/32 drill according to the chart, and just checking with the drawing, and that is in line with the chart, so that's good. So we'll go back and do that. So they told us depth of 236. So for this, depth of 236, could be a 1 diameter if you're using a plug tap. So we'll be using it's okay to tap deeper. That's why it says minimum drilling depth. So anyways, let's go back and we'll start. We'll use their numbers from the drawing. And alright, so back to my B90 270, B90 C270 plane for construction and tool plane. So we'll start off with the spot drill. that hole, that hole, check. And if you remember what it told us for the spot, right here, between 90 and 110 thousandths. Okay, between 90 and 110, so 100 thousandths is right in the middle. So for our spot drill, we'll go 50 thousandths deep. So where'd that sucker go? Spot drill right there. Tool number 9, and to the spot drill on my cut parameters. Let's see, 1.875, and then I want to go minus 0.05. Top of stock. Retract, I'll say 0.3. And I don't need clearance because I'm not going to be flipping the part around. Alright, check that. And I'll hit another drill tool path, and I can hit right here, copy previous points, and then I can hit this little one here, reverse order. Alright, so that way the drill will start drilling the last hole that was spotted, and then it'll go from that one back to the first one that was spotted. So reverse order. Green check. My tool's going to be that 3/30 seconds drill right there. I'll go with a peck drill. 50 thousandths is good. Linking is, so they want us to go 236 deep with the drill. So it's going to be 1.1875 minus 0.236, and then we're going to use tip comp with 0 breakthrough. That's good there. Check, and then we need to tap it. So same thing, drill, copy previous points, reverse, green check. Now the tool is going to be our 256. Oh, okay, STI. So I'm kind of seeing this for the first time when the students that updated this tool list. So you don't want to have anything in parentheses in your tool name, because that gets posted out into your code. And if you remember from your days in Machine 30 of writing code by hand, you cannot have parentheses within parentheses. Now this whole line here gets posted out as a comment, so that means it's in parentheses. So if you have parentheses within parentheses, then you get an error on the Haas machine. So don't want to do that. So make sure you take those parentheses out of that. And what I normally do with the STI taps is I'll actually put a star, STI star, and then on this end I'll go same thing, star, STI star. So it's really obvious that it's not, because you can't, you know, if you use the wrong tap, you'll be in trouble. So sure that's STI. Alright, so we'll go with 10 inches a minute. this should be 560. And this should be 10. Alright. Tap, no PEX. So zero those out. And linking parameters. I'm going to take off the tip comp. And then, let's see, what did they say? They wanted 188 on the tap. So we're using a bottoming tap, so we can go deeper. I'll go 220. Alright, so save that, and then the last video we'll hit the rest of this stuff over here and tab it off.